Okay guys, this is a video for my 40S pre-cal students. I'm just going to go over some practice questions for next week's quizzes. In 3.3 and 3.4, we're going to quiz 3.1 to 3.3 Monday, Tuesday, and then we'll quiz 3.4 Thursday, Friday. But we'll do 3.3 and 3.4 right now. So this will be the answer key. And I can't seem to stop the autofocus on this piece of junk camera that the school has given me. I don't know what to do about it. There is no button that I can see anywhere on the camera that would actually make the autofocus stop from doing what it's doing. It wasn't doing this morning. I can only assume that it hates me. So sorry that it's going to kind of wander in and out of focus. Hopefully you can get a chance to maybe freeze the video and try for yourself to figure out what this equation is. But basically we want to know if x minus 1 is a factor of x cubed minus x squared minus 5x plus 2. So I would say if x minus 1 is a factor of p of x, then p of 1 would equal 0. So let's see if it's true. Is p of 1 equal to 0? So p of 1 would be 1 cubed minus 1 squared minus 5 times 1 plus 2, which is equal to 1 minus 1 minus 5 plus 2. And as you can see, that's clearly not 0. 1 minus 1 is 0. Negative 5 plus 2 is negative 3. So therefore, x minus 1 is not a factor. And you could have, of course, figured that out by also just long dividing this or synthetically dividing and finding that there's a remainder, in which case you know it's not a factor. But this was less work, so I approached it that way. So there's the 3.3, the first 3.3 one. The second 3.3 one, again, you can copy this little question down and pause the video, give it a try. Completely factor this. So if this is factorable, then I'm looking for factors of 3 that I should try. So I should try plus or minus 1 and plus or minus 3. I'll start with positive 1. Does p of 1 equal 0? Well, let's see, that's 1 cubed minus 3 times 1 squared minus 1 plus 3. So that's equal to 1 minus 3 minus 1 plus 3. And let's see, well, that's definitely 0. So therefore, that was nice. The first factor I found was the first number I tried. X minus 1 is a factor. So if x minus 1 is a factor, let's synthetically divide that. 1, negative 3, negative 1, 3, and see if we can find the other factor. So bring down the 1, negative 2, negative 2, negative 3, negative 3, 0. So my p of x actually factors to x minus 1 times, that's 1x squared minus 3x minus 1 and no remainder. So there we go. Does this factor? I think it does. X squared minus 3x minus 1 should factor to x, wait a minute, minus 1, minus 3. Oh, look at that. Did I ever goof that up? Hold on. I misread that completely. That's minus 2x minus 3. I misread my own statement here. I was reading the line above it. That was my mistake. Let me fix that. Minus 2x minus 3. There we go. So does this factor? And I believe it does. X minus 3, x plus 1 would give me that. So I can say that p of x fully factors to the factor I got in the first place, x minus 1 times x minus 3 times x plus 1. And you know a nice quick way to check to see if you have the right answer is, do you get the right constant if you multiply together the constants? Negative 1 times negative 3 is 3, times 1 is positive 3. We're golden. So there's a 3.3. Now the one that might take a little longer. I tried this one in class and I completely goofed it up because I misread it, so I'll try it again. So once again, this is my key. Guess I forgot to write that on the last one. Key. So 3.4. So pause your video and see if you can come up with a sketch for x times x plus 1 times x minus 2. Oh, sorry, x times x plus 1 cubed times x minus 2. There's a couple of multiplicities here. Wow, this is going to be kind of a complicated one. So pause the video and give it a try. Even if you can't get the sketch, see if you can fill in all of this. All right, pause the video and try it. All right, how'd you do? So this is a 6th degree polynomial because it's x times x cubed, which is x to the 4, times x squared, which is x to the 6. Its leading coefficient is a 1, which means that since it's an even polynomial, both its arms go in the same direction, and since it's a positive leading coefficient, both arms are going up at the end behaviors. My zeros, x is 0, x is negative 1, and x is positive 2 would all make this thing 0 if y was 0. And for the y-intercept, remember that y-intercepts happen when x is 0. So that'd be y equals 0 times 0 plus 1 cubed times 0 minus 2 squared. And you can tell anything times 0 is 0. So the y-intercept is 0. And my interval diagram will look like this. So my interval diagram, I'm going to start at, say, negative 1, and then I have a 0 and a 1 and a 2. All right, past negative 1, it's positive because both arms go up. Past positive 2, it's positive. I know that 0, 0 is a point, so there's an interval there. I know negative 1 is a point, and I know 2 is a point. So what's happening between negative 1 and 0? Well, let's see. Let's pick a number that's between negative 1 and 0. Let's pick x is negative a half. So if I have negative a half times negative a half plus 1 cubed times negative a half minus 2 squared. Okay, this is, at the end of the day, I don't really care what this number is. I just care if it's positive or negative. So this is a negative. This factor here is a positive. Cubed is still a positive. And this factor is a negative, but I'm squaring it, so it's a positive. So it's a negative times a positive times a positive. So it's definitely negative in this interval. Next, what about the interval between 0 and 2? So I'll try 1. What happens when x is 1? And I'm going to get this. Whoops. Bah. Am I still on the screen? Yeah, looks good. All right, so, oh, and that's a squared. Okay, so that's a positive times a negative squared, which is a positive, and that means positive, positive, positive. We are positive in here. So, yeah, looks like we are going to have this happen. Now, let's put the graph together based on our information. What do we know? We know that we go through 0, 0. We know that we go through negative 1. We know that we go through positive 2. Then we know that both arms go up. Now, this is where it gets kind of tricky because a 6th degree polynomial could change direction 5 times. So I'm thinking, okay, I know that between negative 1 and 0, it is negative. Actually, you know what? I just realized I drew these very badly. I didn't leave myself any room to make the multiplicities. So let's maybe do that first, right? Let's do the multiplicities. Okay. What kind of a multiplicity is a squared? Well, a squared multiplicity is a bounce. So I'm going to make it a bounce. So bounce, like that. And what kind of a multiplicity is a cubed? Well, a cubed, which happens at this, at the negative 1 x-intercept, that's going to be one of these guys. So it's going to kind of curve, flatten, and then go that way. But, okay, I know that between negative 1 and 0 it's negative. I don't know how far it goes, but then between 0 and positive and 1, or 0 and 2, it's positive. So I think it's going to go down, up, and then it's going to have to change directions again. It might change directions a couple more times, but I actually can't kind of tell that from the data I have. From the data I have, I think that's a pretty good sketch. I have everything I was supposed to have. I have both arms up. I have all of my x-intercepts and y-intercept. I have, let's see, let's check my intervals. Positive, then negative, then positive. Positive, then negative, then positive. And then positive again, which means that's why it was a multiplicity that was a bounce. So, just for fun, I'm going to check on Desmos what we got here. See how close we are. So I'm going to go to display capture and go to Desmos. I haven't even opened Desmos yet. And I'm going to graph this thing, see how close my picture is. So y equals x times x plus 1 to the power of 3 and times x minus 2 squared. X minus 2 all squared. And whoa, oh, jeez. Didn't notice that didn't work. Let's try that again. X minus 2 all squared. There we go. Okay, well, that's not too bad. I kind of exaggerated how far down this dip is, and otherwise it's actually not bad at all. I've got my multiplicity here and my multiplicity here that I did right, and maybe I exaggerated this one too far down and that one too far up. Let's see. Let's compare it again. So let's see. Yeah. Otherwise, pretty darn good. I'd give that full marks if I was me. Easy for me to say. I'm being generous to myself. All right, that's it. Good luck on the quiz next week. Bye-bye.